Hello students, so now we have a topic river crossing in which some of the students get confused how we are solving and what we are doing like that. So from the normal basics we will start and then we will cover everything, how everything works in this. Okay. Before that, river crossing, some of the students have problem with understanding the basic projectile. If you understand how projectile works now, then this is very easy. Okay, this is a thing in front of that. See how the projectile works. First let's see this. Okay. So what I'm saying is, let's say this is u, right? U with the angle theta we projected, right? Velocity component u cos theta, u sin theta. You will come to know why why I'm writing this. Then after we will go to river crossing. Just hold on, okay? Have some patience. Don't skip this part, okay? U cos theta is there. G is downward, right? So there is no acceleration in x direction, okay? Now consider this as particle, okay? When I'm talking about horizontal velocity, okay? With horizontal velocity it is going, okay? Why I'm calculating the time period in the vertical direction, why not in horizontal direction? First understand this thing. When I'm throwing the particle, let's keep horizontal velocity only, okay? Will the horizontal velocity will be what we say giving me the time taken in the projectile or not, that we deciding, okay? So if we have a particle, if we give a u cos theta continuously will going with u cos theta, going it will go, right? Where it will stop? Do we know? No. Why? Because there is no acceleration in x direction. There is no acceleration in x direction. So it will continue with the u cos theta velocity. So this horizontal direction is not deciding my time taken in the projectile, right? Understand? Now if we go for the vertical velocity, u sin theta. So u sin theta, it is going up, zero velocity, coming down and hitting the ground, right? So when it is hitting the ground, projectile over, right? Means vertical direction you have to calculate the time period. Time taken, right? So time taken by the projectile always calculated in vertical direction. This is the reason, okay? Now come to the maximum height. So maximum height means how much height he went up, okay? So that will be in vertical direction. When its velocity got zero, vertical velocity got zero. That is the point when it was at maximum height. So that's how you calculate. Now formula derivation you know already. Apply the equation of motion, you will get the answer, okay? Now range. Now when I'm going this side, like this, it started from here, going this side, and it will hit the ground. That is the point, that is range, right? So means going with u cos theta until what he will go? Till time taken, right? So u cos theta into time taken, time of the projectile. That is your range. That's how you calculate, okay? Now come to river crossing. Why I told you this thing? Come to river crossing. See, first of all, I will mention that what are the things here. So we have river flowing this direction with VR, okay? The width of the river is small d, okay? Man velocity with respect to river is v/m/r, okay? That is generally mentioned. And this is drift I will tell you, just hold on, okay? Now we are taking the first case with minimum time to cross the river, okay? Now first question asked is that, sir, why he is jumping straight for the minimum time taken, okay? That is the first question, okay? Now as I told you in the projectile, same thing apply here. If let's say he goes this side, if he takes jump at an angle, okay? If he jumps this side, right? Okay, so one component of the velocity will be this side, right? One component will be this side, okay? Will this velocity, whatever this velocity is, if you say man velocity will be vr I cap plus vm/r j cap, river velocity will get added in this direction, right? So it have a horizontal component. If I give the vm/r component also, let's say, so vx, right, this x velocity, is this x velocity is deciding how much time it will take? Answer this question. When he is going in the vx, he is continue going, where it will stop? No, it will not stop. Why? Because their vx is not deciding that how much time it will take, right? So means which one is deciding? Vy, okay? Vy. So vm/r, so whatever vy it is going with, right? Vy, okay? This is velocity. And velocity, so I can say distance is small d divided by vy is your time taken, right? Okay, I want the minimum time, so I have to be vy should be maximum, okay? Maximum vy, what can I give? I can give full component to the this side only, right? Instead of going at an angle, I will go straight only because I want the vy maximum, right? That's why I am taking vm/r directly. That's why I am jumping in the river straight. Understood? Because the horizontal velocity, this vx, is not deciding that how much time it will take, right? Vy only deciding, as same as the projectile. In projectile also I said that this u cos theta is not deciding how much time it will take, right? Similarly in the river crossing, understood? That's why we take here that if he wants to cross the river in minimum time, if you want to cross the river in the minimum time, you have to jump straight. Jump straight, full component is this side, goes, he will have this component velocity VR, because of VR it will have this component, so he will go this side also. Now what is drift? This you understood how this came? Distance upon Vm by R for the minimum time. Okay. Now because he have a component VR this side, right? So time taken is okay, time he took, but because he have this component, so in the same time VR drift, what we say, VR into time taken, that is with the horizontal component VR, okay, in how much time it crossed the river. By that time he traveled this side also, right? He have to reach straight, but he will reach somewhere here, okay? So that is known as drift, okay? How much ahead it went, instead of going straight, it went some ahead, right? Because VR is there, right? So VR into time taken, that is distance, right? This is your drift. What is drift? VR into time taken. Got it? The horizontal, right? Same as the projectile. See, horizontal, what we write down? What we write down? Range. What we write down? Range. Horizontal component u cos theta multiply by time taken, right? Same thing we did here. Horizontal component VR into time taken. Understood? That's how. This is what about minimum time. Okay, if you want to cross the river in minimum time. Now second thing is zero drift condition. Now in zero drift condition there are two things. Okay, first you understand this thing. This particular condition I will explain later on. Hold on for a second. Okay, first thing is patience in the understanding the concept. That is the main thing. Okay, now I want zero drift condition. Okay, so I want the drift to be zero. This thing I want zero, right? This thing I want zero. So what can I do? I have one thing, that here VR is coming. Here what I have, VR. Okay, this side, if I'm jumping this side, I will explain why I'm jumping this side. Okay, at angle theta. So this will be what? Vm by R cos theta, and this side what will be that? Vm by R sin theta. Okay, right? Vm by R, basically what is Vm by R, that you understand. If you run right on the ground, you have a different velocity, right? If the same person swims, okay, that will swim with a different velocity. So let's say there is a still swimming pool, okay, and you are swimming in it, okay. Let's say you are swimming with some velocity, right? So the person who is standing on the ground, he will see swimming you with certain velocity, right? Okay. So that's what is this V, velocity of man with respect to river in still water, right? So when you are in still water, how you are going, that is your Vm by R. Okay. Now if the river is flowing this direction, opposite to you, okay, this you are going this side, river is flowing this side, right? What will happen? The river velocity, you are swimming with the same thing, same velocity, right? You are applying the same power to swim, right? But river is coming this side, so it will affect you, right? It will try to decrease your velocity. That's how river is affecting here. River velocity will get added. Okay, so if you are going this side, river is coming this side, so river will decrease your velocity. Maybe possible if you are not fast enough, so you will go this side with the river only, right? Possible. If let's say you are swimming this side and river is also this side, right? So river will support your velocity and you will swim this side. Got it? That's how. So this is Vm by R. I didn't explain initially, so here it is clear. Now see, come back to this thing. So Vm by R, I jump this side. Okay, why I jump this side? Because I want zero drift. What is drift? This side, how much I am displacing, right? That I want to be zero. Okay. Now to that side, it will take, right? To cross the river, it will take time, right? But if I make this horizontal component of velocity zero, okay, I will jump in such a way that I will make this horizontal component. I have the Vm by R, which is higher than VR. Okay, I will come back to this. Vm by R I will jump in such a way that one component will help me to cross the river and one component will balance the river velocity. Okay, what is happening? When river is flowing this side, okay, and you came from this side, and river velocity and your velocity are same, then what will happen? According to me, which is standing outside, right? According to me, you will be stationary only. Understand? So that's what happening here. river is flowing this side and you gave your velocity one component to this side which is equal to VR, so that horizontal component became 0. Now if the horizontal, there is no velocity in horizontal, there is no velocity in x direction, then what will happen? It will not displace. There will be no displacement in the x direction, right? So there will be 0 drift. So this is what we wrote, velocity of man in the ground frame. So this is VR, this side positive, and Vm by r sin theta negative. So this is I cap, total I cap velocity, and this is J cap velocity. Okay. So 0 drift means x direction velocity should be 0. That you understood? Okay. If I want, same, come back to projectile. If I want the range to be 0, what will I do? U cos theta 0. Simple. Do U cos theta 0, it will go up and come down, right? Same thing. That's why I told, if you understand the projectile, this is very easy. In which direction I have to calculate time, in which direction I have to calculate range, that everything will be understood. So if I make the net horizontal velocity 0, then this particle will not go in horizontal direction. So I will get my 0 drift, right? So that's what I did. Vx equals to 0, so this component 0. So from here came sin theta equals to VR by Vm by R. Okay. Now 2 reasons for this condition. First of all, see here, sin theta should be less than 1, right? So VR should be less than Vm by R. That is one thing. Okay. Second thing is, this is to remember. Okay, how to remember. Okay, otherwise this is very easy, you can solve and you can get this answer. Okay, no need to even remember also, but I'm just telling. Okay, sin theta equals to VR by Vm by R. Second reason you understand, if I have Vm by R which is less than VR, let's say Vm by R which is less than VR. Okay, let's say river velocity is 5. Okay, and Vm by R is 3 only. You have the velocity 3 meter per second and river is flowing with 5 meter per second, right? Like let's say this is 3 meter per second and this is 5 meter per second. Understood? Now if you have 3 meter per second, okay, and you want 0 drift, how you will do 0 drift? If you have 3 only, 3 component also you are taking, and then you will equate to 5. How? You will not able to balance, right? So you will have some drift, that we will be discussing next point. Okay, that is a different thing. So this is not possible. You can't get 0 drift if your velocity with which you can swim, okay, is less than the velocity of the river. Because here you said that, okay, I will go in the at angle, certain angle, that will balance the velocity of river. How you will balance it? Even if you if you go this side, then your component have to balance VR. You are not able to balance. How the component will balance? So 3, then you say 3 sin theta also. Sin theta is less than 1. 3 sin theta, na? This side. So 3 sin theta, which is less, sin theta is less than 1. So already you are going below 3, right? So you will not able to balance. That's why this we study in different condition. Okay. So when you will say, let's say this is your, you can flow with, like you can swim with 8 meter per second, let's say. Okay. And river velocity is 5 meter per second only, right? Then what you will say that, okay, 8, I have 8, right? So 8, one component 5 I will give this side. Okay, so 8 sin theta I will take, 8 sin theta equals to 5. I will balance it. Okay, my one component will balance the river velocity and my other component will, by that other component I will go cross the river, right? So this is possible. That's why I write down this condition. Got it? This is how. Okay, so that's how I got the 0 drift condition. This is the 0 drift condition. If your angle, this angle theta with the vertical, okay, this is your VR by Vm by R. Understood? Next thing you see. So here time taken to cross the river. Time taken means what? Time taken will be in vertical direction. I explained already, right? So velocity is what? Vm by R cos theta. Okay, and distance is what? D. Okay, so time taken will be D upon Vm by R cos theta. Understood? This one thing you have to remember, angle with the river flow. Generally what happens is, in the question when he will ask in the module or somewhere in the exam question, generally he will ask what is the angle with the river flow which I have to go with, so that I can get the 0 drift condition. So there you have to, don't answer directly theta. So theta calculated, theta 60 degree came, 60 degree answer you will take, and it is wrong. Why? Because with the river flow, river is flowing this direction, right? You gave velocity this direction. This is your theta, right? So there is pi by 2 also, na? with the river flow, what is the angle of your velocity? That is pi by 2 plus theta. That's how this. Okay. This is also, you remember, this is one silly mistake people make, directly answering theta, you will get wrong answer. Okay. So that's how. This is your time. This is angle with the river. I hope you understood this thing. Let's go for the next. Now next we have condition for minimum drift. Okay. Minimum drift. So you said that, sir, my Vm by r is not enough to balance the river velocity. Okay. My Vm by r is less. Okay. So even if I give a component, if I give component, it will not able to balance the Vm by r, right? So still I want the minimum. Okay. What angle should I go with so that I can get minimum drift? Okay. Obviously I will get a drift because some component I will give this side to balance, and some component with some component I will go up, right? Obviously this side you want a component, you have to cross the river also, right? So you want a component this side also, but you want to eliminate this factor also so that you don't get that much high drift. Okay. So for this condition, how you solve? First of all, we write down the velocity of the man, okay, in the ground frame. So this side, what it will come? Vm by r sin theta. Okay. This side river velocity will be get added to Vr, that is written here, Vr minus Vm by r sin theta. Okay, because this is in negative x, right? On this side, what is the component? Vr Vm by r cos theta. Okay, Vm by r cos theta. Understood? Got it? This is what. Now I want minimum drift. Okay, there will be a drift because this velocity will not able to balance. This velocity component will not able to balance. So there will be a drift. Let's see. So time to cross the river. Time will be how much? Same as that, d upon Vm by r cos theta, right? That is okay. Time is okay, right? In vertical direction, this will be. Now come to the drift. So drift will be what? Horizontal velocity. This horizontal velocity Vr minus Vm by r sin theta into time taken, that will be your drift, right? How you calculated drift here? Understand? Here drift, what you calculated? Horizontal velocity into time taken, right? This is only na horizontal velocity Vr, right? Same as here. So here also you are saying this is horizontal velocity Vx. What you are saying, this is Vx, and this is what? Time, right? So horizontal velocity into time taken, that is your drift. Okay. Now minimum drift. Minimum drift one. How you find out minimum? Take differentiation as 0. 0. That's it. Okay. What is changing here? What can I change here? Angle, right? So differentiate with respect to angle. Okay. Okay. So angle, if I differentiate, d theta by dt will come. That will get 0. Okay. So for that, put it 0. Differentiate and put it equal to 0. So let's differentiate. Numerator, this is denominator, this is constant. Okay. Keep it outside. D is constant outside. Vm, differentiate this, sin theta differentiation, cos theta, right? So this will come 0 minus Vm by r cos theta, and then denominator as it is, Vm by r cos theta. Okay. Minus, okay, this as it is, Vr minus Vm by r sin theta, and then denominator differentiation, this will come minus sin theta, right? So minus minus will get plus, and here Vm by r sin theta. Okay, and denominator you will have, so this will be your this, and denominator also you will have something. What you will have? Gx square, na? What is Gx? Vm by r cos theta square equals to 0. Okay, so numerator have to be 0. Now understand here how it is. Vm by r cos square theta will become, right? So minus cos square theta, and here you will have Vm by r square sin square theta, right? So what you will have? Minus Vm by r square minus Vm by r square, you take common. So here you will have cos square theta, here you will have sin square theta. So that will become 1. So you will have minus Vm by r square. Then here what is the term? Plus Vr multiplied by Vm by r sin theta is equals to 0. This is what it will be. Okay. From here 1 Vm by r got 0. Cancel out. Okay. And sin theta will come. So let me write down. Next page we have. Yes. Sin theta will come. How much is your sin theta here? Vm by r divided by Vr. Okay, this is your sin theta. Understood? Okay, and you can see from here also. See, Vr is greater, right? So Vr should be in denominator because I am writing sin theta. Sin theta should be less than 1. By that also you can remember. But the way of derivation is this: minimum drift, so you put it 0. Okay, d theta by dt will come. That will go outside and getting 0. Okay, understood? So this is how you do it. Okay. So with respect to time, you can differentiate with respect to theta. Okay, let's say with respect to theta only differentiate. No confusion. Okay, that's how the minimum drift condition works. Okay. So this is what about this river crossing thing. Okay, and I hope it will be clear because basic thing is this only, that your time will be calculated in vertical direction. Okay, and your how much drift it will cover, that will be in your horizontal, by the horizontal component, right? Now just one thing I mention again, I will tell you again, that this thing, this condition, maybe you don't understand, you can rewind the video or you can see here. If I have a component, okay, if I am able to my Vm by r, one component is able to balance Vr, well and good, you will not have any drift. Okay, if your even whole velocity is less than Vr, right, then how the component will balance? If my velocity is not able to balance, then component how it will balance? So that's how we have one condition more, condition for minimum drift. Okay, when Vm by r is less than Vr. Okay, this is what. Okay, I hope this is clear. Thank you.